bit school teachery at this point. But it's lovely to have you all here with us. Alicia is just admitting people as they come through to this new platform. So it's all, like I said, this technology is fabulous until it doesn't work. So we, for some reason, couldn't get onto our webinar platform, but as fabulous backstage techs that we are, at the very last minute, we've just changed that through, and you've all diligently and dutifully followed the new link. So it's great to have you here. We will almost certainly have some last minute people joining us as that information just gets rallied through. We've obviously put posts out onto our social media to let people know about the change. Alicia will also be recording this for you. So for anybody that misses the first section, do not worry. This, like all of the resources here at the ABTT, will be recorded and popped onto our ABTT website. So don't worry, you can absolutely catch up with this. So today's seminar is about UVC lighting and the use of its disinfectant agencies, and if it can be used backstage going forward. So I am very much like you. I'm here to listen, to observe. I'm also a voice for you as well. So I'll be the first one to say to Nathaniel, mate, I don't get it. Please explain it a little bit more. So in my very candid way that I do. So Nathaniel has a fabulous presentation for us. I've had a chance to have a little look through that. There's a lot of information there, so but that's why I'm here. So don't worry, we will host a Q&A afterwards. So if any of it was just a little bit sciencey for you, fear not. We will get to the bottom of it and we will work out what it is you need to know about it, how you can use it, any myths that you want to demystify, everything like that. But we're going to give Nathaniel the chance to talk to us about UVC and its use, and then I will host a Q&A afterwards. So Nathaniel, over to you.
Thank you very much. So thank you all for bearing with us whilst we overcame some technological hurdles. As Mig just said, I'm going to talk for probably the next 15-20 minutes about UVC and how it works, how it might work for some of the areas that you guys work in, and then we'll have a Q&A afterwards as well. So if you've got any queries at all, please do just put them into the chat box, and we'll come on to them at the end. I'll also have my colleague Darren Smith. He's our systems architect. He's with me today as well to field any of the really particularly technical questions, which I know I will stumble upon. Without further ado, I'll start the presentation, and yeah, as I say, do just pop those questions in, and hopefully we can have a nice interactive session towards the end. So just to give you a little bit of information about who we are, because when people say Signify, they probably think, who the heck are these guys? So Signify is the new name for Philips. It's fairly new. We changed our name a couple of years ago from Philips Lighting to Signify. You are probably more familiar with Strand Verilight, which is one of our brands which we operate. It's one of our luminaire brands. It's all part of the Signify family. We're still the global #1, but we decided to change our name a couple of years ago. It just gives you a short background there. But onto UVC, because that's what we're here about today. So back in April of this year, I volunteered to head up the UVC activity that we're doing in the UK, because we decided that as well as our lamps, we were also going to bring forward a range of luminaires for UVC, which would help tackle coronavirus. It's been really interesting for me. My day job typically was working with retailers and hotel groups. So actually it gave me an opportunity to speak to customers from lots of different areas to understand some of the challenges that they faced, how they sort of initially came out of lockdown 1, how they've been coping with all the safeguards that they've had to put in place and so on. But ultimately trying to find a way to help these companies go from being kind of 50 to 60% open to trading to as close as possible to normal, in order to make sure their businesses are viable. And obviously we believe UVC is one of the ways which companies can address the need for biosecurity in the world that we currently live in. So we're going to do a bit of theory now, and I'm going to show you a video from a German university. Before I play that, I just want to sort of explain a couple of things. So I'm going to, throughout this presentation, I'm going to refer to 3 ways that viruses are transmitted. This video gives us a really cool way of showing how these pathogens spread throughout the air. And what I'll do is when I'm talking later on about the solutions that we offer, I'll come back to this idea of the 3 transmission routes and how we're tackling that with UVC. So hopefully this will start. There we go. Okay, so this is a school rather than a theatre, but it gives you an idea of how that dirty air spreads throughout a room. You can see that the pupil here is patient 0, and as they're coughing and sneezing, you can see that blue air is coming out of their mouth, and that's the dirty air. Now, hot air rises through natural convection, so you can see that blue, all those blue particles raising up into the upper part of the room, and they're going to spread over time. This brings us our first route of transmission. So we have direct airborne transmission between people. So if you're sat close to this person, unfortunately, you're more than likely to get whatever they've got. You also have indirect airborne transmission. So if we've got a air conditioning system in this room, for example, if you have a duct around here, it's going to remove that dirty air and take it out through the duct, potentially take it through some sort of filter, but then previously, before COVID, it would have been recycled and put into another room. And then the third route is indirect surface-borne transmission. So all that hot air is in the upper part of the room. It's rising through natural convection, but at some point it will cool, and all of those dirty particles will fall onto surfaces. Ultimately, then you have this issue where your tables, your chairs, whatever, will be covered in the pathogens that has come out of that person's mouth. So they're the 3 key areas to keep in mind. And as I said, we'll come on to those again throughout the presentation. As a result of that cycle, really the reality is that bacteria and viruses are everywhere. So you know, in the past, that wasn't such a huge deal. I think most people accepted the fact they may get sick once, twice a year, particularly in winter. But with COVID and the threat of that, clearly it's really focused everyone's mind on, okay, how can we make sure we ensure the wellness and safety of our staff, but also give people the confidence to come out to our shops, to our theatres, to our bars and restaurants, and so on. So onto UVC specifically and how it works. So ultraviolet light is invisible to our eyes. And we divide it into 3 categories. So we have UVA, which is 315 to 400 nanometers. We do experience this in the natural world. So this gives us our suntan in the natural world. It's also used in commercial applications such as sunbeds and insect traps. UVB is not so great for us. We do experience this in the natural world, but it causes sunburn. But there are also some medical applications, so it's used in phototherapy and things like that. UVC, however, is something which in the natural world we shouldn't really experience. It doesn't penetrate the Earth's atmosphere, and it's anything from 200 to 280 nanometers. Now, at some point in the last 50, 60 years, some bright spark discovered that actually it's really effective for germicidal disinfection applications, hence why we're here today. And why we have some really great stories about how UVC has helped different people in disinfection. So a little bit more detail here. I really like this image in the top right because it kind of sums up what we are doing with UVC. So UVC doesn't kill anything. It basically just breaks down the DNA, the RNA of the bacteria, virus, or the spore. So it basically renders that organism completely inert and completely harmless. So if I had a UVC light source above my desk here, I turned it on, it would effectively irradiate that desk, and you may have a cold or flu virus on there initially. It's effectively still there, but it just will do nothing to you because it's rendered completely inert. We've used UVC for over 40 years. So in certain markets, it's very normal. In Russia, for example, if you're sick and you go to a hospital, it's more than likely you would have a UVC light above your bed in your patient room. That's just to disinfect the air as it's circulating around the room. And we've also got use cases in agriculture and all sorts in the US. So it's a really varied proposition for us, and has the ability to be a really powerful disinfection tool. It's something of a step back to the future. So we are using conventional lighting for UVC rather than LED. That's for a number of reasons, really. LED isn't quite there in terms of the technology, in terms of the price point, power efficacy, and also the lifetime of the chips. So for now, UVC uses conventional lighting, and we're really happy with the performance of that light source. To that end, I've got the graph at the bottom right-hand corner, which shows you that our lamps run at 253.7 nanometers. So that's close to the peak effectiveness for germicidal applications. Now, one thing that we did want to do is really bring UVC up to date. We were confident, and we know that there's no virus or bacteria that can currently stand up to UVC, but because of the impact of COVID, we wanted to have it verified by a laboratory that actually our lamps are effective. So we partnered with Boston University, and they confirmed that our UVC light source inactivated 99% of SARS in just 6 seconds, actually. So that was really great news. And obviously then in the context of COVID-19, means that people can stand by the claims that UVC is a viable disinfection solution. So that's kind of the theory to one side now. What I want to talk to you about quickly is safety. So like any disinfection system that you come across, whether it's bleach or UVC or anything else, it has to be used correctly. Otherwise, it's likely not safe. So if you don't use UVC correctly, it will cause quite a nasty sunburn type reaction to your skin, and it will also damage your eyes. That damage is temporary, so your eyes would recover within probably 72 hours maximum, potentially even just 48 hours. That being said, I would not choose to sit in front of a UVC lamp with my eyes open. So it's really important that depending on the solution that you're looking at, you think about the safeguards that you might need to deploy, and I'll come on to that in a bit more detail when I talk around the solutions. So in order to really try and make sure that everything that goes into the market is not just safe, but also fit for purpose and delivers a value to the end user, we've introduced a mandatory certification process. So this means that every distributor and electrical installer that we work with, they have to do a certificate and also sign up to our contractual addendum, which outlines some of the nuances and safeguards that people need to keep in mind. This is really important. It means that if you are the operator of a theatre, it gives you the confidence to know whoever's installing this kit understands how UVC works, and means that ultimately you're going to hopefully get a really good solution which adds value to you and helps you on a day-to-day basis. It should go without saying, but all of our products follow standard product safety releases and approbations, so CE markings and so on and so forth. And although this is probably not relevant for you guys, I do just need to say that no medical claims can be made. So what I'm saying here is that we can't say that UVC can be used in operating theatres and so on, but different kind of theatre. So hopefully no one is having open heart surgery in any of your facilities. Now, alongside safety, dose calculations are a really important part of what we offer our customers, particularly those that are looking at surface disinfection with our battens. When we're looking at a scheme with surface disinfection, we want to understand a couple of things. First of all, what is the aim of that disinfection? So are you looking just really focusing at removing SARS-CoV-2 or COVID-19 from kind of your problem, or are you looking for something much broader and you're looking to target, say, different mold spores or salmonella or so on and so forth? That has a direct impact on how much UV we need in the room in order to deliver an effective disinfection for you. The other thing that we look to understand is how much time we have. Again, you know, if we have from closing until opening, and so we effectively have 5 or 6 hours, then actually you might only need 1 or 2 battens in a room. If you say to us, actually, I've got 10 minutes to do a disinfection because I've got to turn this room around really quickly for the next people that are coming in or something like that, then actually we take that into account, and with our calculating software and light design software, we'd work backwards to say, okay, if we've got 15 minutes, then we need X number of battens in that room, which is going to be significantly more than if we could do, say, a 3-4 hour exposure. The table here gives you an idea of the dosage we need for different bacteria and viruses. So we've got highlighted here SARS-CoV-2, which causes COVID-19. That needs 18 joules per meter squared. To give you something to compare it to, we've got quite a lot of material from universities and studies and so on that talk about tuberculosis. That's much tougher to eradicate. That takes 60 joules per meter squared for log 1. So it's around about 3 times as durable against UVC. So when I come on to the upper air, I'll talk about TB a bit more. It just gives you an idea of how effective that might be against COVID-19. So on to some of the nitty gritty. We divide our products and solutions into 4 categories, really. So we have air disinfection. These are upper air units which are mounted either on the wall or on the ceiling of rooms. We have surface disinfection, which is delivered via our battens. Object disinfection, which we use our UVC chambers for, and currently in development, so should be released early next year, is our mobile trolley, so mobile disinfection. I'm going to go into a bit more detail now around each one of these and give you some examples of where we've used them. If you've got any questions up until now, please do get them in the chat box, and we will, as I say, come on to them at the end. So, air disinfection. I think this is by far and away the one that has resonated most with customers that we've spoken to. This is intended to be used when a room is in use. So it could be, we've had dance studios looking at using this for their rehearsal areas. We've also had offices looking at deploying this and canteens and so on, because you can put these in the room. They create effectively a UVC mesh in the upper part of the room, and that then disinfects the air. If you think back to the video from the start, with all that warm air coming out of someone's mouth as they coughed and sneezed, it's all going up into that upper part of the room. So by creating a UVC mesh above, it means that all of that hot air will just be irradiated, disinfected, and then by the time it cools and drops down, it's completely clean. We've got some really good case studies for this solution against tuberculosis. So if anyone does want a copy of that, we're happy to share that with you. And then the last point here I just want to touch on from this first paragraph is around equivalent air change per hour. So if you think about an office environment where you maybe get 2 to 3 air changes per hour with your air conditioning moving air around, this really accelerates that. So there's no moving parts, doesn't have a fan in it, it just has the UV light source and the air moving around the room as normal. But through the studies that we've done and the software that we use, we know that we can achieve anything from 18 to 24 equivalent air changes per hour. So what that means in real terms is that over, say, a 15-minute period, you're getting up to log 4 disinfection of the air. So that's going to protect your staff and your customers against COVID-19, but also against general transmission of cold, flu, coughs, colds, that sort of thing. So the way that this works, we do have the ceiling mounted here and the wall mounted. The ceiling mounted actually comes with a mounting tile, so it slots in really nicely. It's a really easy installation. And each one we typically say covers about a 20 square meter floor space. So we wouldn't expect to use this actually in a theatre itself. Where we would see this adding value is around your food and beverage areas, communal areas, offices, those sort of areas. The challenge with the theatre itself is the height and also just the volume of air and making sure that this was out of eye line of people who were at the theatre, for example. I really like this slide because it just gives you the idea of that UVC mesh. So this is for a kind of office environment, but hopefully you can use your imagination and think how this might be used in, say, your bar areas or so on. You have here the air moving around the room. You'd have hot air rising. As it goes through the field, it's just irradiated and ultimately drops down. So again, going back to that video that I showed you at the beginning, this really counters all three of those transmission areas. You will vastly reduce direct airborne transmission from person to person, because as that air is leaving this person's mouth, it's going straight up and being irradiated. If you did have an air conditioning system, you're also going to hugely reduce the amount of bad air going out through the HVAC system, because again, it's being disinfected through this field. And lastly, you're going to reduce the amount of surface-borne transmission, because all of the air that's cooling is going to be irradiated and disinfected. So you're reducing that from anything from 40 to 60%, according to the studies that we have. So it's a really powerful solution. And just to give you an idea of some of the places where we've used it, we've got some great pictures here of a gym that we've recently done over in Holland. And this is also an office area as well. So they don't look completely out of place, you know, in any setting really. They're fairly discreet, and hopefully you can see where that might add some value for you. Moving on to surface disinfection. So this is a little bit more of a niche. We're finding more and more people are thinking actually, you know, air disinfection is one of the ways which, or quicker way for them. However, there are definitely some use cases where we see this adding value. So, for example, you could have it in a communal area like an office, where you want to disinfect tables and toilets, for example. It gives you that extra layer of protection to ensure that that people are kept safe. What we would say here is that because it's a bare light source, there are more safeguards. So for the upper air units, they're engineered to be used whilst the space is occupied. The light is controlled in such a way that the light is pushed up onto the ceiling and it's kept way out of eye level. And it means it's safe for you to be within that space all day long. With the battens, it's bare light source. So you have to use this when the space is unoccupied completely. So we would expect to see quite a few safeguards in place in order to make sure this was not just effective, but also really safe. So we would want to see motion sensors, for example, shown here. You may have a siren. You probably don't need a siren, but it may be worthwhile depending on what the room is used for. We would anticipate having door locks so that the system would only energize when the doors were shut. If the motion sensors failed, we'd really want to see a second fail safe. So that's in the form of an emergency stop shown here on the drawing. And then lastly, you may have a warning light on the outside. So it's not overly complex. Hopefully it's all fairly common sense, but for surface disinfection, certainly we would expect to see slightly more in the way of thinking, okay, how do we control how this room is used, who can access it, and so on and so forth. Another use case we've had recently is around using UVC within sort of an X-ray tunnel So where in airports you would x-ray baggage, actually we're seeing people develop these tunnels for different people, so for hotels and so on, but basically putting it through the tunnel and using UVC to disinfect it. This is a computer lab installation. So this was a university that approached us and said, look, we're doing lots of additional cleaning, but actually we want to be really sure that at the end of the day, we're doing a really deep cleanse of the room. So they're deploying UVC to deliver that. This was quite a tricky one because we not only were looking to disinfect the surfaces, the horizontal surfaces shown here, but actually also the vertical surfaces. So if you think about light hitting those surfaces, horizontal is dead easy, but actually you're going to get less intensity on the verticals. So in our software, we had to sort of draw up the whole room and all the furniture. And this is why it was taking 25 minutes. If you were to say to us, actually, the only vertical surface is the chair leg, so actually I don't need that to be disinfected, it does make it a quicker exposure time. What I can also give you as well is the options that we propose. So in option 1, we had 15 luminaires, and in option 2, I think we had 10. So you can see the difference in exposure time from 25 to 46 minutes with those. Object disinfection is actually something which we found has gained more and more interest in your sector, actually. So because you have so many things moving from person to person and being shared around, particularly at live venues, the chambers have been really of interest to people. You could disinfect anything from remote gear for musical instruments, microphones, and so on and so forth. And really just looking at particularly targeting the transmission where you're going to have things being passed from person to person. These are innately safe in the sense that they only turn on when the door is shut. UVC can't penetrate glass, so we know that that's safe as well. And because you have such a high intensity of UVC in these chambers, you can do a COVID cleanse in just 2 minutes. Or if you want a broader spectrum log4 disinfection where we disinfect 99.99%, then it's 5 minutes. This is really handy if you've got quick changeover, you're trying to just keep on top of that disinfection. It's a way for you to deploy this in a really safe and quick manner. Okay, and then the last one that we just wanted to go through was mobile disinfection. So, as I said, this is due for release early next year. And the idea here is it takes all of the strengths of the baton with surface disinfection, but rather than having to commit to having a permanent installation, you can actually have mobile and therefore be able to use the same units in lots of different areas. So typically this should cover around 30 square meters, so it's got a really good footprint. The idea would be that you could wheel it into a space, you'd move away, turn it on remotely, and then it would either turn off after an allotted time, or it's got motion sensors as well. So as soon as you approach it and come in within the field, it will turn itself off. We're currently looking at trialing this with a hotel chain. So for them, this is sort of particular value for when they're doing room changeovers. So at the moment they're having to pay a couple of extra pounds for PPE, and then also probably an extra 15 minutes per room. So across, say, 100-bedroom hotel, that cost really stacks up. So what they're planning to do is revert to their standard cleaning regime, and then at the end of that cleaning regime, the cleaner will wheel in the trolley, turn it on, move on to the next room. By the time they've finished the second room, they can walk back around, pick up the trolley, and move it over to the second room, do the disinfection. For your arena, this obviously works in all of your public areas. It could also work in dressing rooms, corridors, toilets, and so on. So it's a really good way of, again, in conjunction with other cleaning, helping to offer an additional layer of protection. So just to summarize, hopefully I've given you a really good flavor of what UVC lighting can offer you. We believe it's just as versatile as general lighting, and there are niches and pockets where it can really add a huge amount of value and probably do things which you're going to struggle to achieve through other means. That being said, it is only part of your disinfection toolkit. So we're not saying that it will solve all of your ills, but we do see areas where it can do a fantastic job against other solutions which are currently available. All that being said, the safety aspect is absolutely critical. And for us to really help deliver an effective scheme, it really helps us to understand how you're using the space, what you're looking to achieve, and we can therefore work with you and with your installers to ensure we deliver a compliant and effective scheme. So without further ado, I think we'll go to the Q&A.
Thanks, Nathaniel. Thank you.
No problem.
Mig had, I'll tell you, it's a day of technical issues for me. So it's a good job you sent it through to me, because I did miss a little section where I had to log back in there. I don't know if anybody noticed that, but there we are. Lovely. So that being said, I have caught up on all of the questions that are there, but unfortunately I haven't got your name. So do shout me if I haven't got one of these questions right for you. So hopefully now you're all just like me, like completely understand it now. Those graphs made perfect sense, blah blah blah. Of course, no, you did a great job, Nathaniel. There's lots of graphs to decipher there, and there's a few questions, and hopefully we can sort of have a little bit of discussion. I don't know if you're anything like me. It's quite exciting that this exists. You know, in theory, it sounds relatively simple, and it could be added to our arsenal of disinfecting tools that we could use going forward. Of course, it always comes down to cost, which I'm sure we can get onto later on. But let me try to get through some of these questions. Just bear with me, because this is not the best platform for that. So Alicia and I will do our very best to try and get through some of these questions for you. So so the first one that I thought was really interesting, actually, and apologies for not knowing who it was that asked it, was a lot of the guidance talks about open air and about how being that's the best way forward. So the question is there a measure for the number of air disinfection exchanges that would be equivalent to open air, or are we not comparing it in that way?
So I tried to answer the question at the time, actually, Mig. So okay. It's very difficult to compare it to open air. What we can do is compare it to traditional air changes from heating and ventilating systems. So Nathaniel had a slide there which says that typically an indoor space will have 5 to 6 air changes an hour, and with the correct dosage of UVC, we can increase that. So rather than the HVAC system having to work harder, having UVC in the space can, you know, equate to something like 18 air changes an hour. Yes, we know that the guidance is to use, you know, open air ventilation as much as you can, but in actual fact, there's no way to measure that, because we can't take into account, you know, how strong is the wind that day. If you've got windows open on one side and the other, therefore the air is passing all the way through. So the examples that we can do, and based on our work with ASHRAE and if you like, calculation and simulation software, is look at a space where, you know, it's not ventilated by natural air but via an artificial system like an HVAC system, and how we can contribute to that. So it's very difficult to compare to outdoors.
I thought so, yeah. Okay. And what are the visible light implications in a dark space like a theatre?
Yeah, it is a really good question. Sorry, Nathaniel, I'm diving in. You've done a lot of talking, so I'll give you a break. Yeah, so whilst there was not going to be, if you like, a lux level that's added to the space, we can't get away from the fact that there is a blue hue. So I saw that, Terry, you came back and asked for further explanation on that. When these units, like the upper air units, are on when people are present, there is a blue hue to the lamps. So we can see that they're on. And it may be that in those environments where you've got to have this pitch darkness, that that potentially using the upper air solutions aren't the solution forward, and we probably have to focus more on the surface disinfection so there is nobody present, and we just go for using UVC when the rooms are empty and used in a controlled environment. But we can't get away from the fact that UVC lamps do have a blue hue to them, and you can see that they're on. That's done purposefully so that we know that they're on.
Okay, and lots of questions about soft furnishings and seat coverings and things. How effective are they on costumes and soft furnitures? Because there's lots of questions about how we clean those things. And is this the solution, maybe?
So I think one of the challenges, I can see one of the questions, I think it's from Martin, about seats that tilt. Also, one of the challenges is certainly the fact that UVC does need line of sight. So if something is in the shade or sort of obscured so the light can't get to it, then the UVC just can't be effective. Darren, I don't know if you know it or can share sort of it in a nutshell around UVC and its impact on fabrics and
No. So UVC is absorbed by fabrics, so we know that. So it is an effective use on fabrics. But you're absolutely right. Line of sight is imperative. So if a seat is tilted up, then we can't see it with the artificial light. But in terms of a flat surface, you know, with the chambers, we do see people using their face masks in the chambers to disinfect them. So, you know, and a face mask is typically made of fabric. So that is an application for the chamber of people putting in a face mask to have it disinfected and had any pathogens or bacteria on it broken down. So it will work on fabrics.
Someone's asking about the distracting level of luminance referred to. So are you aware of any additional light in a theatre that's unacceptable whilst this particular one is running?
Yeah, I saw that question. We can't get away from it. You know, the lamps are blue and they're on. And that's why I'm saying that if the upper air solutions and you have direct line of sight of them, even though it is from a distance, they will be visibly on. We tried to put the louvers on the fittings to control the direction of UVC, which should keep it above everyone's heads. That's the whole idea of using the filters for control. So that we limit the exposure to the eye and to the skin. But I'm not confident that you wouldn't see that they were on. My fear would be that there would be a blue hue.
Yeah, I kind of read that question slightly differently, more along the lines of if there other lights were left on when these lights are on, does it somehow affect the output of them? So like if the cleaning lights were left on overnight, for example, whilst you were running your UVC lights, would there be any adverse effect to the UVC?
Perfectly fine. I mean, if we think about a commercial office where we've installed this already, even areas that have got natural light, the UVC lights can be on at the same time. They're not adversely affected by other light sources.
Okay. Apologies, that's two versions of us understanding that question. I hope that whoever asked that, we answered both aspects of it, whichever one was correct. I can see how this helps with aerosols, but what about droplets we hear about, which fall to earth faster? Would there still potentially be contaminated surfaces in a room with upper air luminaires?
Yeah.
Yeah. Go on, you go. Go on.
I was just going to say, so the data we have is that typically with an upper air system, you're going to reduce the amount of surface-borne pathogens by between 40 and 60%, depending on kind of the characteristics of the room. So you will still get some surface-borne pathogens, there's no doubt, but it does reduce the amount that you're going to get. So you could, for example, deploy upper air. You get all the benefits of the air disinfection from person-to-person transmission. You're going to hugely reduce the amount of surface-borne pathogens, and it then means it's maybe a bit more manageable to maintain that disinfection through just your FM team going around and doing their standard cleaning.
I think this one's been answered, but I'm going to ask it anyway because it's just about, you talked about direct line of sight and disaffected areas directly exposed. Any kind of, does that work if it's refracted or reflected in any way? Is there any benefit?
We take into, yeah. I mean, we have to, when we do our calculations, so we've got simulation software that we use that would take a space and put the UVC solutions in. We take into account the reflectance value of ceilings and walls and floors. So we know that they will absorb some of the UVC, but they'll also reflect, but it's very, very minimal in terms of reflectance. So you'd probably end up need an awful amount of UVC to even hope that it reflects off a surface to work. It really needs to be that direct exposure. That's what we calculate. It's the irradiance on a surface for a certain period of time that gives us the dosage calculation that we need, or the dosage output that we need. And it kind of lends onto the question, sorry, Mig, that we've seen there on a trolley. You know, to combat some of the challenges that we have with line of sight, where, you know, things are hidden by other objects, we then are looking at this mobile trolley scenario where it can be moved around. So you get different angles of exposure to UVC at different points within a room. So in a large space, it might be that we calculate there are 5 ideal locations for the trolley to be positioned, and it's left on for a 20-minute period each time. So in location 1, you set the trolley up, everyone leaves the room, the trolley turns on, it does its disinfection process for 20 minutes, turns itself off. You then go back into the room, you move it to another location, it goes on for another 20 minutes, and so on. You repeat that process to ensure you get all of the different angles of incident that we need on a surface to disinfect them.
Cool, lovely. I'm going to just read this one out because I can't profess to understand it. So I'm hoping that one of you do as well. So I'm sure I'm not the only one here who was hoping to hear about UVC systems inside HVAC ducts. Can we have some news on that, please? So perhaps for those of us that don't know what a HVAC duct is, someone could explain that before we go on to answer the question. That would be good. Yeah,
it's cool. No problem. So HVAC, heating, ventilating and air conditioning systems. And obviously you've got these ducts that run around that are pulling and pushing air around a building. And it is something we are exploring in terms of putting UVC lighting inside ducts. The problem and the challenge with doing it this way, and I get it where everyone looks forward to hearing about it working this way because it's not visible, it's hidden away, is there are a number of other factors that play into the usefulness of HVAC and UVC. The first one is filters. So on the front of all these HVAC systems, you've got filters. Those filters aren't being irradiated by UVC and need to be cleaned on a regular basis for it to be even worthwhile looking at it. The idea that a bacteria or a pathogen might rest on the vent means that we might be cleaning the air that's actually in the duct itself, but as soon as it goes through that vent, it's infected again, which has made that whole process of putting UVC battens or tubes inside the ducting pointless. The other thing is the speed of the air that is moved inside the ducts is far greater than it is when you're actually inside a space. So, you know, we've Nathaniel and I have had some quite extensive training on fluid dynamics, and I've got to be honest with you, it's a whole new level of science. But the air inside a duct moves a lot faster than it does when it's in open spaces. So the dosage required and the amount of units required in ducting, it's quite difficult to calculate. It's extensive. So we're still working on it. We've got a number of partners where we're seeing how we can develop the ducting systems. But where we're at right now today, it's air disinfection in the space, it's surface disinfection with battens or trolleys and chambers. So I guess it's watch this space when it comes to ducting, but as it stands right now, we can't give any guidance on that.
I think just to add one thing to that as well, I think the challenge you have with an induct solution, like Darren says, you have this situation where potentially some air particles will be massively irradiated and be really clean, but other air particles may not get a full dose. But actually, if you're in the room where all this dirty air is being moved around through convection, actually you're going to have a lot of people getting infected before that air is taken up by the HVAC system. So actually it doesn't really achieve much. You know, you're not going to protect the people in the room there and then, and that's why, like Darren says, having a system that's actually in the room, in the space, disinfecting, offers much more protection to the occupants rather than having battens in the ducting system.
Lovely. I'm still with you and I'm amazed. So you're doing a fabulous job. So I'm definitely the layman person in the room. So I'm still with you. This one is about degradation to fabrics, particularly concerned about the effects on rigging equipment, slings and harnesses, those kind of things. Does it affect those things?
Yeah, so typically when we've seen the use of UVC on, if you like, polycarbonates and plastics, historically it's had a detrimental effect of it, making it brittle. So what we're doing is a study with a number of manufacturers to look at how much UVC exposure these materials can take before they start to degrade. So what I would say at this point is, yes, there is a level of degradation to being exposed to UVC. So i.e. discoloring of fabrics and maybe the change of a paint that's on a wall. But the key thing here is it's over a long period of time. So it might be that we're talking about a year's worth of exposure or 18 months worth of exposure, nowhere near the exposure time that we're talking about for the treatment and dealing with the disinfection of surfaces and air. But what we hope to do in the next 2 weeks is get some results of these initial studies of what prolonged exposure to UVC is on other types of materials, and release those so people can get an understanding of what that is. But to answer the question, yes, there is some degradation to other materials when they're exposed to UVC, but it's not drastic.
I think there was a couple of questions on that, so that's great. So this one is, are you developing the general table or software to calculate how many fixtures will be needed to use either on disinfected tunnels or in ventilation equipment? I believe you did mention that there was a calculator somewhere.
So yeah, we do have software, but we're at this stage not releasing it. And the reason for that is we're working with ASHRAE and a couple of other governing bodies to develop that software. And at the moment, what we're...
Oh. You can unmute, Darren.
Somebody muted me. Am I talking too much? So yeah, Mig, I'll go back. Yes, there is software, but at the moment we're keeping that software in-house, just as we're managing it forward. There are numerous different methods that people are using for calculating it, but what we tend to do is follow a process of auditing, so that we get an idea of what is experienced in a space, colors of the walls, ceiling, furniture, etc., and then building that in a software model very similar to a lighting design model. I would say that the software that we are using isn't our own, it's a third party, which is why we're not releasing it. You know, it's not ours to release to the world. It's just something that we're comfortable and confident of using. And in all cases, when we're looking at UVC, it's important that the qualified people are there installing it. So Nathaniel mentioned that there is a number of training methods and a number of training regimes that, you know, our contractors are going through and our own staff are going through before a system is out there and installed. So we firmly believe that these safeguards need to be in place. We've seen some terrible usage of UVC. You know, Nathaniel talked about how harmful it could be to your skin and to eyes, but still, there have been examples of an airport putting UVC lights at the check-in desk to disinfect people, even though we've been saying how harmful it is. So there is an absolute need to make sure this is used in the correct manner. So at the moment, you know, any UVC manufacturers out there will be giving guidance as to how to use it safely. And we would encourage that all those methods are followed.
So is it safe to say then that even though this is harmful, there is nothing that says that you're qualified to do it? Like, people can still get this product and gung-ho, willy-nilly go and plug things in and do stuff in that.
Not from us.
There's
Not
no
from us.
legislation in that sense of if someone came to you, for example, and asked to dry hire something, would you dry hire it without your expertise linked into it in some way? Or do you see what I mean? Am I making any sense?
No, you are absolutely making sense. So so because of the certification process that we have in place, we're basically tracking where all of our products are going. And that's really to make sure that people are putting the right safeguards in place, understanding how the system works, but also fundamentally making sure that whatever gets installed actually will do the job. Because we don't want people to injure themselves, but also what we would hate to happen is for people to spend a boatload of money on a system which actually is ineffective and doesn't deliver what they're looking for, and then they've not just wasted their money, they're also putting people at risk of either damage and harm or just not being protected. So the certification process is really key to managing that. And also we're working with key partners for distribution and also for installation as well. So that hopefully should mean that ultimately we get really high competence people in the marketplace reselling this and also installing it in a way that's safe and effective.
So the products that you discussed that in your presentation, you would absolutely go into a space and recommend whatever the person might particularly need for, and spend some sort of part of the consultation process, I guess, of what the right product is for the right job, if that makes any sense. Okay.
Yeah, absolutely. Yeah.
And obviously that's encouraged as well.
Sure.
Okay.
Yeah, no, definitely.
So this one's quite interesting. I'm not going to profess to understand it. I hope you do. Will there be a luminaire that combines LED white daylight and UVC to allow retrofitting in offices and communal areas? So I'm wondering. I don't really understand. Does anyone else understand that? Is it
I'm
maybe
cool
retrospectively adding something in to a
cool
unit?
With that. LEDs are nowhere near ready to be, if you like, released in the UVC market at the moment. They're nowhere near as efficient as fluorescents. So we're using, if you like, an old fluorescent tube technology to achieve the efficiencies that we need at the moment for the correct UVC output. So to combine UV output with the traditional white light output of LEDs it's tricky on two fronts. One is, how do we ensure that it's not being used when people are present, which a traditional white light would be. So there is a challenge with that as well. But the main one is that the amount of exposure you'd have to an LED that's emitting UVC, i.e. the surface exposure time, is so long that you'd never actually get anything disinfected or any of the bacteria broken down. So I think we're a way off from seeing LEDs being used, and I would challenge the idea of doing it in a if you like, a retrospective kind of replacement scenario. I genuinely think these systems have to sit aside from general illumination.
Well, they for a health and safety point of view,
absolutely.
They need their own emergency shut-off procedures and
correct.
Whatever else. So from what I'm hearing, everybody out there, there's a fair amount of risk assessment and risk management to consider integrating this system into your building, and you would need certainly, I would imagine, like as a chief electrician, I would absolutely want to have like a master control for this, and that nobody else can accidentally turn these on, and it needs to be worked into your production schedules and perhaps your overnight shut-off structures as well.
What we've seen, Mig, as well, is building it into building management systems, so that as soon as a security alarm is set, because everyone has left, then the UVC comes on and starts doing surface disinfection. So we try to automate the process as much as we can as well, whilst having all these manual overrides.
Okay, so obviously a sound person out there that's asking about if the cabinet example would be suitable for cleaning fragile radio mics and transmitters without causing any damage to them.
Yeah, it's an absolute use case for it. We've seen it with retail, with using handheld equipment that they have within the stores. The staff are using it, putting it into the cabinets overnight so that it has its treatment and then used the next day. So yeah, it's a use case. We do see that used.
Just because we're sort of a way through the seminar, can we just clarify? I know, Nathaniel, that you had a lovely chart that told us how long the virus needed to be exposed to UVC. There was one on specifically corona version of the virus. Was it? I can't remember it off the top of my head.
So
Can you just remind us how long?
Well, it was 18 joules, so it wasn't a time period.
Oh,
it was just the dosage needed.
And how? And just I don't know if you know this off the top of your head, but how long would one need to give the doses of 18 joules? Do we think?
So I'm going to give a really annoying answer. It depends. So so with the testing that Boston University did, they got to log 1 disinfection. So that's disinfecting 90% of the spores. They got to log 1 within 6 seconds, but that was probably with the light source, you know, a couple of feet away from the Petri dish. So it's not really a real life example. That's very much laboratory sort of testing. So you know, if we were looking at surface disinfection with batons, you're probably looking at anything from 15 to 25 minutes, depending, you know, having a reasonable amount of batons in the room. You know, if we could pepper the ceiling, then we could probably do it in a couple of minutes, but that's not realistic. So if you're looking for surface disinfection, you need to allow that kind of budgetary time, 15 to 25 minutes typically. And then for the upper air, that's works slightly different because that's working on a fluence rate, a dosage rate of the volume of air within that space. And we sort of reflect that in the equivalent air changes per hour. So we try and obviously get that as high as possible to show that the added value that that system is going to offer in comparison to, say, natural ventilation or like Darren was saying, around air conditioning.
But we can take the chamber as well, right? You know, the chamber has a setting of around about 5 minutes for the disinfection of objects when you're targeting COVID-19 or the SARS-CoV-2 bacteria that causes COVID-19. So its objects go in for 5 minutes. If we were tackling E. coli, then it's slightly longer. It's like 15 minutes. You know, the first studies when looking at things like tuberculosis, it was 30 minutes. So it really does depend on the pathogen and the bacteria that you're hoping to target in terms of how much time we're talking about with UVC exposure.
Cool. I think everybody at the moment is just trying to tackle the one pathogen. I don't know about anybody else, but I think we all just want to eliminate COVID-19. But yeah, is there anything, if these systems were put into place, is there any kind of test? I mean, obviously short from bringing the virus in and checking that it disappears, obviously nobody really wants that. Is there some sort of guarantee or something whereby we can kind of know that our system is working properly? Is it, I want to call it a test. I feel like that's probably not the right word for it, but do you see what I mean? If I was going to install it in my theatre, I just want to be like, are you going to come in and just give me the thumbs up that this is going to work? How would you know that it's working, that I've got a sufficient number of these UVC lights in order for it to be useful to work?
Yeah, it's a really tough one, that. So I think the challenge that you have is short of taking samples and sending them off to a lab, how do you verify? And even doing that, you know, you're not going to have the same sort of scenario on each day. So if you did a pre-installation air sample, for example, say if you have 10 people in that room, it could be that all of them or none of them have some sort of bug or contagion. And then after installation, if you do another sample with 10 people in the room, again, it could be that some or none of them have a bug. So then how do you compare air samples and so on? So it's tricky to do. I think what we can absolutely stand by, and this is why we've done it, we've partnered with the university so that they have verified that efficiency and the effectiveness of our light sources against SARS-CoV-2. we've got multiple university studies centered around upper air and UVC in general, and the efficiency of that to show, you know, how it is effective against all of these things. So you kind of got the theory there. We're happy with that. We can stand by that. We've also got the software where we can calculate irradiance doses and so on surfaces and the fluence rate in the air. So with all of those different pieces of the puzzle, we can put together what we would stand by as a credible and effective solution. And that's really, sorry, Darren.
So just to add to that, you know, there is a commissioning process for every single one of our calculations and our projects. So, and our teams carry an irradiance meter that will measure the amount of UVC that is being generated by the system that's been installed. So whilst we can't test to say you are bacteria free, what we can do is ensure the amount of UVC that's coming out is being effective.
Now that's cool. I mean, I think that pretty much answers my question in its effectiveness. Do you know what I mean? Because obviously we don't.
But there's a question in the chat from Fifi. Great name, Fifi. Thank you. But the UVC lights during their usage do actually degrade. So it is important that we carry out these measurement tests. We tend to recommend that we do them every quarter to check that the amount of UVC that is being generated is still effective. And we recommend that after 9,000 hours usage, that the lamps are replaced. So what does that mean? If they're on all the time, then you are looking at replacing lamps once a year. You know, if they're on for half a day, then you're looking at replacing lamps every 2 years. But there is still this irradiance meter check to ensure that you've got the right amount of UVC that the design originally intended to have being carried out on an ongoing basis.
Okay. Let me chuck some sort of rapid questions at you then. So is the trolley battery operated, or will it require power via a cable?
You're on mute.
Oh, sorry, my bad.
No, you're not. Nathaniel was. He was answering.
Yeah. Yes, it would need power. It is not battery operated.
I think there might, if you wanted to develop something, I think people would quite like a remote one to wheel around. You mentioned that glass stops the UVC. Is this any glass? Would a room with glass windows be safe if viewed from outside whilst the units are on? Do we need curtains? Yes.
Is it 2 millimeters or 3, Darren, or what's the thickness? Do you know?
3 millimeter glass.
There you go.
Absorbs UVC, so you get a very, very low transmittance and reflectance value. So we use glass on our tubes, right? So the UV is generated and pushed through glass, but we're talking about it's, you know, less than a millimeter thick, the glass that's on the fluorescent tube. But what we do say is for glass windows that are in excess of 3 millimeters, then, you know, they are effectively a blocker to UVC.
This one's really simple, but I quite like it. So it's if UVC is a good solution, why is the government and experts not advising this use more? Fair question. I suspect they've got other things to worry about, but yeah, fair question.
So it's a really fair question. I saw that a few minutes ago, and so I was hoping we'd get round to it. It's really tough. I think if you look at UVC on a global scale, it has been deployed by governments in different markets. So in South Africa, in Russia, in the Far East, it's used as a norm. It's well established. For whatever reason, over the last 40 or 50 years in Western Europe and the UK, it's not been heavily adopted by governments and by businesses. We're hoping that's going to change because we are lobbying government. We're sort of submitting business cases and submitting material to say, look, this could be a viable option. For example, we're working with DCMS around sports clubs, so with rugby clubs and football clubs, looking to say, look, can we support with the reopening of stadia by deploying UVC and explaining to them how it works. So we're kind of doing that work now. I think the challenge is that because historically the feeling has been, well, we've got other disinfection regimes that achieve what we need in order to sort of ensure a high enough level of biosecurity. We are coming from a standing start, so it will take time for this message to go through to government, but we do hope that will change in the not too distant future.
Great. So there's another question just about power consumption. So yeah, what are they juicy? Do they take a lot of power?
No, not especially. So each upper air unit is around about 30 watts. So it's not huge. Obviously that scales up. So I think someone earlier asked about kind of tables and whether you can work out kind of just roughly how many you need. So with upper air, it is a bit more simple. We can sort of quickly say that each one covers 20 square meters. So if you had, say, a 90 square meter room, you're going to likely need 3 of the upper air units. So you're looking at sort of about 90 watts for that room.
And yeah, this is a really good question actually from Travis about the disposal of them. So obviously we all know that we have to dispose of our flory tubes in a certain way. Do these need special consideration?
Same way as a normal fluorescent tube.
Cool. Okay.
You don't have, there's no special disposal of them.
So Nick is talking about, I guess his concern is about the foldable seating and about if there's any merit in using UVC or not, because obviously it's not got line of sight onto the seating. Is it better if he just reverts to cleaning? I think you've probably almost answered your own question there, Nick. Probably, in that sense, but he also goes on to say that there might be a benefit to dressing rooms and props.
I think Nick's hit the nail on the head there. I think, and hopefully I've been open enough in the presentation. UVC has huge benefits for certain applications in certain areas, but there are other areas where it's just not the right solution. So I would agree with Nick. I don't think in the auditorium by default you would use UVC. I think there might be some instances where it would work, but I would say generally that's not where you're going to see the value. I think you would see more value in, like you say, in changing rooms, dressing rooms, in toilets maybe, and then also so I don't know about everyone's business case and how they operate, but it may be that the bar area and restaurant areas for revenue and generating turnover. So actually being able to open those areas up would really support commercially. So actually having UVC in those areas could add a lot more value. And typically those areas have standard ceiling heights. So it's much more easy to deploy a UVC solution like upper air, for example. But I think this comes back to what you're saying, Mig, about the consultative approach. There's no point in trying to shoehorn a UVC solution into an area where actually it's not quite going to work, and we'd sort of be really open about that at the initial stage of an inquiry.
It's a really good question here actually about obviously you talked about lifespans of these lamps and stuff. If we don't know the degradation, how do we monitor this? So, do your luminate, they're not self-monitoring lamps in that sense. So
the chamber is
visually check them, or
no, the chamber is self-monitoring. So the chamber measures how long the lamps have been on for. We even issue some UVC cards that you can put into the chamber and run a test cycle to see how effective they are. But there's a digital readout on the chamber that says lamps have been burning for 7,000 hours. We recommend you change them in this time frame. So the chamber, we can actually do some kind of measurement. With the systems, again, there is a way if we were to put, talk to the BMS system or something else just to get an idea of how many hours the tubes have been on for, and sticking to our guidelines of changing them every 9,000 hours. That's always a good rule of thumb. But the most effective way is to get that meter and carry out that test of the UVC effectiveness, is to know when to change it.
Great. Okay, so there's one here about some, I don't know whether this is true or not, this is just someone writing this. So some European countries have advised against the use of UVC outside of medical applications. I'm sure you guys know more about that, whether that's true or not.
So I think it was Belgium banned it for about a week, and then they unbanned it, or debanned it. I'm not sure what the phrase is, but I'm not sure of any other European countries that have done that, and we're certainly operating throughout the EU with these solutions. We've got teams across every market selling this in, so we haven't come across that issue.
I think the concern is always going to be the misuse of it, and we were quite startled by the fact that there was a UVC wand put on sale on Amazon that people could buy. And when you dive further into the technology that they're using there, it's a much lower wavelength of UVC, which you'd have to expose a surface for 72 to, almost a week for it to be effective. The whole idea of the UVC solutions that we are promoting is that they are fast and effective. And that's the most effective way to deal with the virus.
Lovely. So we've got about 9 minutes left, and I should probably address the elephant in the room, if you don't mind, which is how much does this cost? Obviously, we're not here to listen to like a sales pitch or listen to. I'm sure you don't want to go through your entire catalogue, and I'm sure that you can contact these guys directly. But is it going to break our ever dwindling bank balance? Probably. Let us know. Can you give us a rough idea?
Yeah, look, I can. That's fine. So one thing to say is obviously depending on where people are at with budgets, there are potentially funding options available as well. So we'd have to look at that on a case-by-case basis to see whether that's an option. It's tough to sort of give you full pricing because we would typically have an installation partner who would do the installation. So I can give you an idea of the product cost, but there's also the installation cost, which people need to bear in mind as well. So Phil's asked about the mobile unit specifically. You'd be looking at around about £2,000 for those. The pricing hasn't been confirmed yet. That's the indication that we've had from our teams, our colleagues in the central team. So that hopefully gives you an idea. But again, there could be other funding models that would be introduced, such as rental and so on. So, I think there are different ways that we can wrap that up to make it a viable option for people. For things like the upper air, that again really depends on the quantity. You're looking at around about £800 per unit, and then obviously it depends on how big your space is. So if you probably all scribble that down. If you work off the 20 square meter rule, then you can work out roughly how many fixtures you'd need. In addition to that, you've obviously got the installation cost. There would be a survey and commissioning, like Darren said, to actually verify that the UVC is operating. So there are a few additional costs there to include, but it gives you a ballpark idea of what you'd be looking at. I think the batten is a bit more difficult because there's a few more considerations to have. So if you think back to that slide where I showed you the aerial view of the room with all of the safeguards and so on. So your batten cost is one part of it, and you're looking at anything from £100 to £150 per batten. But then you are going to have to think about the occupancy control and the controls in general and the safeguards and so on. So, you would probably be almost doubling that cost over a project. So if you had 10 battens at 150, you would then need to add another £1,500 on at least for all of the safeguards and things like that. So hopefully that gives you a kind of a ballpark idea. I know I've been recorded, so I'll have this in perpetuity. You guys know our pricing, but I want to be as open as possible to give you an idea, and you can then think about yourselves and your own situations, if there are areas that you think actually this could work really well, you can sort of have a think yourself about how much this would cost for you.
I love the fact that as soon as you started talking about cost, we get a question that says, does anyone else make these?
I'm not sure you're going to get an honest answer from Nathaniel or Darren.
I know there's loads, but they're rubbish. So,
I will add.
Be fair to Signify, I'm not going to mention him, but I've had a few other people contact me. I must say that in terms of how organised and structured they are in terms of presenting themselves, Signify were very, very quick to contact us and to do that. But there are obviously, because it has merits, there are other people out there.
But what I would say, Mig, is that we manufacture the tubes. And a lot of these other manufacturers that are out there with systems have got Philips technology inside their systems, and they are partners of ours. Absolutely, and they are people that we know are following all these guidelines that we've spoken about. So, whilst they are seen as competitors, they're also partners that are out sending exactly the same strong message that we are. So, the answer to the question is yes, there are, and there are some good ones. It's just the bad ones to filter out.
I think, fair play to you. I think you've been very. I'm not going to lie to you. I was a bit nervous about this one, and I thought I wouldn't follow it, but I'm still here, so it's all good. And I hope that nearly 100 of you are also still here, and that it's somewhat been demystified a little bit. So that's pretty much most of the questions. I'm really glad that we got through that for you. We've got 3 minutes left to this session, so all of the information that's come through, I know a lot of you are asking about graphs and studies and things, and I'm sure that Signify and Nathaniel, Phillips, everyone are more than happy to share all of that, and Alicia can converge all of that into one page, which will be your resources that are available for this seminar. So you can go onto the ABTT website. Obviously you can of course contact Signify and Philips directly for any more information, but we will house it together as a resource page for this particular seminar. I think the key thing that I've learned from this, that is, although it's very effective, we should also be very respectful of the technology and perhaps not endeavour to go out there thinking that we know everything about it. But obviously in our industry, risk management is what we do. So I would hope that everybody would look at this responsibly and work out whether it's worth using in your working environment. My only other question was just if there are any case studies on it, but it's still quite new, isn't it? This is what I was talking to you about before, if have any theatres used it yet? Have you seen anybody that's used it? And if they do, can you please share it? It would be the first thing.
Yeah, so not yet, unfortunately. For theatres, we have got some case studies with some football clubs, so kind of loosely connected to theatres, I guess, in the fact it's entertainment. So we've done some work partnering with Red Bull Leipzig, I think it is, Darren, isn't it?
Yeah, RB Leipzig, yeah.
RB Leipzig. And we should also have some press material coming out soon with Ajax and PSV as well, hopefully.
And I know, again, it's not strictly theatre, but from a hospitality point of view, there is the gym now that is complete and installed, where we are looking at larger spaces where people are active and walking around. So, but that case study is now released as well, which we can share no problem. So
I think if you're anything like me, if you were going to consider something like this, I'm sure you'd want to have a little read about how somebody has successfully integrated this into their system. So if you want to know that information, just get in touch with Nathaniel or Darren directly.
Yeah.
Again, if we can get hold of that information, we'll post it on the ABTT website as a resource. So yeah. Thank you very much for coming. Thank you all so much for being so incredibly patient with us as we completely changed our platform for delivery for this. Thank you all for being so respectful with your microphones and your video. Sort of seamless, somewhat. but we got there in the end, and it was a very, very interesting topic. So it just remains for me to say it again. Obviously, my partner in crime, Alicia, none of this can happen without her meticulous organisation. Even when technology fails, we find a way to still keep these things going. So it's great that we could still host this and not have to rearrange a different time. Thank you very much for all of those resources, guys, and thanks for taking the time to demystify it and explain it to us. Obviously, all of our seminars have been hosted by the Association of British Theatre Technicians. We are a membership organisation, and we are here for you. We are here to make sure that all these resources are available to you. If you feel like joining our family, come and join us. At a time like this, it's really good to stay together. There's lots of member benefits. Alicia will pop a post there. Come and join me. Come and join my ABTT family. Look after yourself in the lockdown. I know that lots of venues have had to shut, so make sure that you look after one another. We are planning some other seminars. Stay in touch with us. If there's anything that we haven't discussed that you would like to see us discuss, get in contact with the office and we will do that for you. But look after one another during this lockdown, and hopefully we will see some faces December-ish, maybe, when we're allowed out again. Thank you very much, everyone.
Thank you so much.
Thanks, Meg. Thanks, Alicia.
Yeah, thank
Bye.
you. Bye.